what I want you guys to think of, let's do, which one was it? Drawing the angles is easy, right?
Yeah.
You didn't have to do the draw the angles of the radians yet, though, have you? We haven't done that, right? Okay. Let's, before I get to this whole coterminal stuff with the angle, with the radian angles, let me just show you guys how you would do, drawing angles that are in radian form. Because if we understand how to draw an angle in a radian form, getting the coterminal stuff is really quick, okay? So let's see. If I'm going to look at 2 pi over 9, what I do is I plot my stuff like I would normally. I have 0, pi, and so on and so on. 2 pi over 9. Is 2 pi over 9 more than half? No. So it's somewhere in the first quadrant. And there's your 2 pi over 9. That's all you have to do for that. Okay. If I go to negative 7 pi over 6, negative 7 pi over 6, well, I don't go counterclockwise, I have to go clockwise. You okay with that? Now, 7 pi over 6, that's more than 1 pi. Do you agree? How much more than a pi is it? 1/6. So what we do is we spin it clockwise past pi, and then we come up 1/6. So we came up off of this pi over 6, but our angle was negative 7 pi over 6. Remember yesterday when we were writing these things out, sometimes I was saying, hey, how far up or how far off the x-axis you were? I was asking you guys to kind of keep tabs on that. There's a huge, the reason that we were doing that is because when we get to a problem like where it was 24 pi over 7 or where it was, it's very easy to count your degrees off, or so your radian measure off by knowing how far it is. Okay. Not bad. 19 pi over 12. If I'm going to go 19 pi over 12, well, 12 goes into 19 how many times? 1, and how many are left over? So this is 1 and 7/12 pi. Are you okay with that? Now, if I'm going to go 1 and 7/12 pi, we're going counterclockwise because it's positive. Here's 1 pi. Then I look at my fractional amount. Is 7 over 12 more than half or less than half? More than half, so that means it's going to come through here. I've passed 6 over 12. I came over another 1/12. Are we okay with that? Which means how much further would it have to be to get to here? If I came over 1/12, it has to go 11. Wait. Yes, because that was another half. So this would be another 5/12 up. You're not going to see 12ths very often, just so you know. But we came down. Here was 6/12 plus 1/12 means there's another 5/12 to get back up to make the full time around. Okay. So by knowing how to do that a little bit easier, as you start talking about those whole coterminal ones, which was these guys. Two goes into 13 how many times? 6. So this is 6 and 1/2 pi. You okay with that? Which means I have to count, place it. 1 little, 2 little, 3 little pies, 4 little, 5 little, 6 little pies. And then how much further do I go? Half. And I wind up there. Now, when I line up on one of the axes, whether it's the y-axis or the x-axis, that position is called a quadrantal. I'll describe that later, but you hear me slip and say the word quadrantal, that means I'm on an axis. I can be on the y-axis or I can be on the x-axis. Okay. Bless you. So right off the bat, we know that this is beyond. One full revolution. But since it wound up on that 90-degree part, that pi over 2, you know that the first coterminal angle, positive, would have to be pi over 2. We okay with that? I could subtract out 2 pi, and I get 4 pi over 2. Subtract out 2 pi, I get 2 pi and a half, and then I get pi over 2. You can back it up the same way, but if you place it first, you might recognize that it lands on there. Do that anytime you have something that has a denominator of 2, because that means that's one of the 90-degree angles. It just depends on which one it lands on. So you have a coterminal angle positive at pi over 2, which means I just have to go the other direction. If I go the other direction, well, here's negative 1 pi, negative 3/2. Because each one of these is a half. Negative 1/2, negative 2/2, negative 3/2. Those are my two angles there. Okay. Not as bad as you thought, maybe?
I did it all wrong.
I was doing it
And that's fine. And we're just adding, I've got more of these for you guys to do today. It's not a big deal. We're just going to do a lot of, I want to make sure we get the whole idea of spinning and putting the coterminal angles and stuff like that together. I fully anticipated that, and it's normal. 4 goes into 17 how many times? 4. You have 4, and then you're left over with 1/4. So right away, if I just cover up the 4, because I can subtract out 2 twice, what's your positive coterminal angle? Pi over 4. Very good. If I spin it to place it, 1 little, 2 little, 3 little pi's, 4 little, 1/4 is halfway up. So it's pi over 4 in the first quadrant. If I subtract out 2 pi twice, I get pi over 4. That's my positive coterminal angle. Okay? Now, if I'm going to go the other direction, the negative direction, if I think of this in terms of fractions, 1 full revolution negative with a 4 as a denominator would be negative 8 pi over 4. That would be 1 full revolution down. Do you guys agree? Yeah. But you had to back it up 1/4. So the negative coterminal angle would be, there you go. By understanding how far something bounces off one of the axes, by bouncing off just the x-axis, as you spin things around, whether it's positive or negative, you'll know whether or not you have to add to something or subtract something to get your positive and or negative coterminal angles. It's all spatial. This is some of the most visual math that we have, like pure number-wise. It's not like conics or anything like that. This is actual distances of value. It's the nerdiness in myself shows with this stuff. I kind of did the 24 pi over 7 yesterday. Want to do that again? 7's a weird denominator to have. What's that? We will, yeah, we will. 7 goes into 24 how many times again? It was 3, so this was 3 and 3/7 pi, I believe. Yeah. So as you go to place this one to start with, 1 little, 2 little, 3 little pi's, 3/7. Is that more or less than half? Less than half. So it's going to stop. The terminal side will be in the quadrant 3. I moved off of this axis, the x-axis, 3/7. Everybody okay with that? Now, the reason why I wanted to say that is because later when I spin stuff around, I know that I have to make sure it's that far off of pi. Okay? So my positive coterminal angle if I just subtract 2 pi from this, was what? 1 3/7 pi. Or 10 pi over 3. To be honest with you, this, like I've said this before, this is probably one of the very one or two places that I think that mixed numbers have really any use at all. If you use a mixed number to write your positive or negative coterminal angles, by all means, perfectly fine by me, because sometimes it's easier to count like that. All right? And then to do the negative. Doing the negative one's a little bit different, because we don't count off the y-axis. If I come all the way up here at negative pi, that would be -7/7 pi. Would you be okay with that? I had to move it back 3/7, which means the negative coterminal angle would have then been -4 pi over 7. Does that make sense? Because I only want to get this far on it, not all the way up. I'm going to back it down. That value there, I think I mentioned this yesterday, it's called a reference angle. The reference angles allow you to always figure out how far something bounces off an x-axis. That's all we ever use, are reference angles. You spin it, you figure out what quadrant you are in, and then you figure out how far did you bounce from an x-axis, because then you can place anything else into that space. You know how to spin back around for another coterminal and things like that. Reference angles are huge. All right. Is the cloud of secrecy and the fuzziness somewhat evading us? How to go from degree to radian? Slap a pi next to it, divide by 1/8. 3 goes into 16 how many times? 5. How many are left over? All right. So this is 5 1/3 pi. So if I spin 1 little, 2 little, 3 little pi's, 4 little, 5 little pi's, and now I have to move off that x-axis 1/3 pi over 3. I move down pi over 3. Since that is beyond 1 full revolution, all I have to do then is figure out what that angle would have been within 1 full revolution. So by just placing it, knowing that if I go positive, here's 1 pi, add a pi over 3 to it. So as I get to pi, that's 3 pi over 3. Add a pi over 3, and you get 4 pi over 3. Good. If I go the other direction, same basic idea. If I went the full route, I would have gone -3 pi over 3, because that's 1 full pi. But I bounced back 1/3. So it would be at, very good. As you bounce back, because the reference angle tells you that you're that far off the axis. And that's how these work. You all right? All right. Does that help? Wow. Are you guys not awake because it's not even like normal class time yet, or what? Jeez. You guys need to get more sleep.
Oh, I got 4 last night.
4 hours of sleep? 4 minutes of sleep. Well, I'm guessing I'm not going to be able to get to arc length and area stuff today, so. But we'll do arc length area stuff. I know yesterday we started to try to draw this stuff in. I'll give you guys one of these probably tomorrow also. What I have though is I made a thingy with positive and negative coterminal stuff. Just a whole bunch of list of things to help you guys through, both in degrees and in radians. And then drawing angles as well to try to get the idea of how to do that. We have not gotten to the sectors or arcs or anything, which is fine, but the answers are on it to help you guys do it, okay? That way you can do this, you've got your notes stuff from there. We'll add sectors and arc lengths tomorrow, and then go from there. Let's see.